So if we have the cantilever beam and on the torsion P, and here I want to calculate the strain energy due to transverse loading. And so sometimes we're using the V, okay, for notations. So now for this example, we want to calculate what is this one. So now for here, first one, I draw the shear moment diagram. For the shear moment diagram for this case is pretty much like this. And this is 0, and V equal to minus P. So for here, you can see in any cross section, doesn't matter which cross section we pick, the value of the V is constant, equal to P. Okay, so now we put into our formulations. U will be equal to the volume integral QG and tau square and dV. And in this case, we plug in tau equal to that equation here, 3/2. And for example, here the cross section here. The cross section has the width B, and this is 2C. Okay, to match our notation here. So the V already we know is A V 1 minus 1C squared. And dV, simply use our notation here, that is B dy and dx. Okay, so for this case, we can implement this one. We'll simply do this carefully. So let me fix the integrand here. So that is 3/2 V over A, 1 minus y over C square. And this is tau square. Okay, and 2G. And dV is become B dy dx. And so from here you can see the integral becomes integrations y from minus C to C. And again, I have utilized the notation C, so integration from the bottom to the top. From the bottom is y equal to minus C, 0, positive C. Okay, like this one. And what is x? Let me pick up the x measured from here, if the whole length is equal to L, so that integration is from 0 to L. Okay? And look at this equation carefully. You can see this is only have the constant in terms of y, so everything is very straightforward. So we can turn up is 2g. Okay, fix this one, and this is 9/4, and v square and a square, and that is everything here. So that, and then integration of respect to dx, that pretty much is constant. So that become L, right? So leaving the integration with respect to y only, and that is 1 minus y over c square dy. Okay? So do the integration carefully on this term. So, and then eventually what we will get is this one. And here again, here one more time, the v equal to constant. The magnitude, how about in this way? Okay, that's the same. So we plug into here, so everything will becomes into here 5GA 3P squared L. And yes, I don't know why.
You don't know why, but
yes.
Where did your B for dy dx go? Third line up, yeah. Where did
B.
the B go?
Yes. B should be here.
Okay.
Yes. Y
how
is
do you
5. Y is 5, and I believe, okay, if we implement this one, okay, let me implement this one. So that is integration from minus C to C, and 1 minus 2y over c squared plus y over c to the fourth, right? And dy. So this one is y and minus c to c minus 2c squared 3y cubed minus c to c plus c fourth and 5 1 y to the fifth minus c to c. Got it? So I believe that could be coming from these terms here.
But you haven't integrated. Wait, that's
Got
after
it?
you integrate it.
Yeah. Okay, so right now I'm integrating this term, and I believe 5 should be coming up from there.
But then what about the?
Then you just simplify. So from here to here
yeah.
probably will take a few minutes. Trust me, this is the calc one.
No, I'm not doubting you on that. It's just I want to see the steps where you get your solution.
Yeah, so that is here. You want me to do it? Okay. So
No,
there's a 2c
there's more than just that.
minus
though.
2c cubed and 8 2c3 plus 5c to the 4 and c fifth 2c fifth. Okay, so c 2 minus 3 4 plus 3 5 2 c 15, so 30 minus 20 plus 6, so that becomes 15, 16c. Hopefully.
16?
Is that right?
Yeah.
Okay, help me to debug my
Oh,
calculation.
yeah.
Okay, so basically that one becomes plugged into here. So 9 fourths v squared a squared times lb 2g times
16,
16 15 c. Oh my goodness. So this is 8. So divide by this one, this is 2. And this one is 5, this one is 3. Okay? And so that becomes and a equal to b squared times 2c squared. So that is 4c squared, right? Are you right?
Yeah, squared.
Right.
Yeah, because it's a squared.
Is that right?
Yeah.
Yes, okay. And this one is p squared. And c go to here, right? So this one cancel this one. So bc equal to a. And
It would be 2BC, so the 4
so,
completely
yeah,
goes away.
so this 2, right?
I know the 2 goes away because it's 2BC.
2 bc, okay, thank you. So that come to here.
Yeah.
Great? Great. Okay, you just try to test mine. I haven't done do this one a long time. Okay, so basically trust me, this should be right. And I can tell you in these chapters, most of the exercise for you, for us, spending will be on this part, the integrations. And as I pretty much finished the preparation of the homework, and I looked through every step in the homework solutions, and I found the most of the time I spent is on the integration, this part.
Cool.
Yeah, very cool. So now, so that is for all the 4 types. So right now we have the axial loading. We talk about the strain energy, and we have the torsions using double arrow. So we have the strain energy that we talk about, and this one we have the pure bending. Then we talk about this one, and then transverse loading. That's the 4th type. So basically for every single loading type we talk about in mechanics materials, and here we have the individual terms here.